So I'm going to start with some brain tests, and if you're holding anything in your hands, I want you to put it down. So the first exercise is very simple. You are going to see some things on the screen, and what I want you to do is to say what you're seeing as fast as you can and clap as you do it. And I want you to do it loud and as fast as you can, and you're not competing with your neighbor, you're doing it with yourselves, okay? So I will do the first one. So hold on, I'll just show you how it goes. So you do this, blue, red, green, yellow, okay? So ready, hands up, go. I can sense a bit of distrust in the room. Another one, go. Good, that was faster. Now we're going to do another sequence. Instructions are the same. State the colors you see as fast as you can. And I'm going to give you a little clue. I am not tricking you yet, okay? And the objective is still the same, as fast as you can and loud. Ready, go. Some of you didn't trust me, did you? Go again. Not, you're fine on this slide. Ready, go. Great. So guess what I'm going to do to you? So you know what I'm going to do to you, and you have to state the color you see as fast as you can. Ready? Go. Okay? Ready? Try again. Next one. Okay, one more. Are you ready? Silence. Ready? You're good at this now, right? So do this one fast. Go. So I'm sort of in two minds. I obviously don't know this group yet so much, so I can do two things. I can either explain to you why this is happening, or I can wait and tell you much later in the presentation when it comes in the flow. So just on the way the brain works, if I don't tell you why this happens now, you're going to have a spark of curiosity, so it may mean that you pay more attention to the whole presentation. But the brain also gets very busy with a little problem it has, and it hangs on to it. So if I don't explain this to you, you may not listen to me, and then so I sort of want to see what we have in the room. If you'd rather have the explanation now, raise your hands. Okay. And if you're happy to wait, raise your hands. Okay, so the brain is a very curious little creature, so the curious ones have won. It's a very simple thing. The brain reads by a slight tiny millisecond faster than it identifies color. So while your brain knows what it has to do, the brain is sort of lazy. And it says, I know that I'm supposed to be identifying color, but actually reading is easier, so just forget what Cristina said and go with whatever is easier. So if you are a lizard and you're out in the wild and you suddenly see this coming up, what are you better off thinking? That it's a rope or a snake? Yeah, snake, right? Because if it's a rope, everything is fine. If it was a snake and you thought it was a rope, then game over. So in a way, the key motto for them is find lunch rather than be lunch. So you want to be paranoid and assume everything in front of you could be there to eat you, and then your chances of survival are higher. And if you look across animals, the animals that are most clingy and most paranoid survive longest. So you take things like scorpions, they've been around for a very, very long time because they are quite nervous and they're always watching out for danger. So that has helped them survive. So what happens is that as human beings, because we have that functionality wired in for 300 million years, that's where we spend most of our time, even though we think we're these rational human beings who are always doing neocortex type stuff. But the reality is our biggest driver is the thing that has been running for 300 million years fairly successfully. So while we don't notice it day to day, we're looking at everything as if it was going to eat us. And to take this a little bit further, if you take the average person, we have about 1 thought per second, which means 60,000 thoughts per day on average. What percentage of that do you think are new thoughts versus repeat thoughts? So what percentage would be new? Take a guess. How much? 0.1? Okay, that's a little bit negative, you see? And you'll see the brain is quite negative. So about 95% of what we think are repeat thoughts. We're just going over and over the stuff we've thought about, particularly if it's a negative thought, right? If somebody did something to you, you're like, I can't believe they did this to me. And how many times do you tell yourself that for years to come? Now, how useful is that? Because you know they did that to you. You know you think that they are idiots. But you keep on telling yourself this as if it was really useful new information. Now, of the 95%, which is a repeat, what percentage do you think is positive versus negative?
28.
28, that's my father's favorite number. Good number. Is that the positive or negative?
20 positive.
20 positive. Any other thoughts, bids? Now, I've already sort of, set you up for imagining something quite negative. So it's 75 is negative. So the average human being spends 75% of their day thinking about repeat negative things. And 20% on positive but repeat things. So they're good, but you're just, using that space in your brain to go through the same thing. Only 5% roughly is new. And if you take the split of positive, negative, a tiny percentage is positive and new. Yeah? Now, it varies by individual. So some people are obviously more positive and more negative. And there is a neurological reason for it. I mean, part of it, of course, is attitude. But part of it is the way your brain is wired. So some people have more activity in their left prefrontal cortex, which is a part here in the brain. And if you have more or less activity there, you will tend to be a more positive or negative person. So part of that is wired in. About 50% they think is wired in. Now, those of you who are thinking, 50% is already wired, what's the point? I can tell you which side of the spectrum you sit on. And those who are saying, great, I still have 50% to play with, then that's probably telling you something about the activity in your brain.
And those saying that we can change.
You absolutely can change. So there is something called neuroplasticity, yeah? And I'll talk about that when we get to neural pathways, but basically, brains are constantly changing. So right now, as you're sitting there, hopefully listening to me or daydreaming or doing whatever you're doing, your brain is changing. So you are literally having neurons light up in a different pattern, and that's creating a new pathway in your brain. So the brain is constantly changing. And there is a lot of research where, people have big accidents, and let's say they lose their hearing, their possibility to hear, to do something. Now, there's a part of the brain that is usually associated with hearing. You can actually, if that's completely damaged, you might be able to learn how to hear from a different part of your brain. So that's all about neuroplasticity and rewiring the brain. So absolutely, we can change.
Is this synesthesis? Is this
No.
like synesthesis?
No, synesthesia is when you hear a flavor, so that's where basically the cabling in your brain gets a little bit mixed up, and so you start combining different senses. Okay, so here is a brain truth. The brain is fairly paranoid, and it has an inbuilt negativity bias. Because we come from reptiles, or our brain started with reptiles, whether you like it or not, whether you're positive or not, the reality is that your brain is wired to be negative. So let's talk about the social aspect of the brain. What makes us different when we're born compared to other animals? How are we different? Pretty useless. Why is that? Why are we more useless than all the other animals?
Because we need the connection to grow. The brain.
Yeah, but look at the picture. There's a hint. Exactly. It's the walking bit. So if you look at all other animals, and the more primitive they are, the faster they get up on their feet or whatever it is they get up on, and they move around. So they can basically go and get water, food, whatever they need to survive. Human beings, if we followed that principle, which all animals follow, the whole idea is that you should stay in the womb for as long as it takes your brain to develop enough that it can control the body. In other words, you should stay there until you can walk. So in human beings, that would mean stay there for 2 years. Yeah? So who has had children here? How would you feel about, oh, sorry, I meant women, had like physically. I'm like, whoa, a few men raised their hands. So you gave birth, you gave birth somewhere 9 months or a little bit earlier. I don't have children, but from what I hear, it's sort of painful. Imagine if you had to wait 2 years and then give birth, right? That's just physically probably not possible. The birth canal can't deal with it, particularly because our head is so big. So we are born ridiculously premature. Of all the animals, we are the most useless beings when we sort of come out. If I gave you a math problem, you would be engaging the sort of rational part of the brain. If I say rest for 1 minute, and I'll give you the next problem, as soon as I give you any slack, most brains will tend to go to something social. You'll immediately start thinking about, what your partner said, what your children are doing, how annoying your boss is. Your brain goes to people, usually. So when the brain is idle, its favorite network is the social brain because we're obsessed with it. It was our way of surviving when we were born. So let's do a little test. I'm going to give you 2 logic problems, and let's see what happens with your brains. Very easy. So there's a rule, which is people under 18 cannot drink alcohol. Each person is holding a card which has the drink and their age. So I'm going to show you 4 cards, and you have to tell me which 2 cards you need to turn over to make sure the rule is not being broken. Okay? So, and do me a favor, just raise your hand when you have the answer. Don't shout it out, just raise your hand. Okay, see several hands going up. Okay, so what's the answer? Whiskey and 15, exactly. So, you don't care what the soda drinker is doing or the 25-year-old, whiskey and 15, okay? So now, next question. Cards with even numbers will always have blue on their opposite face. Each card has a color on one side and the number on the other side. So I'm going to show you 4 cards. Which 2 cards do you need to turn over to see if the rule is being broken? Raise your hand when you have the answer. Gosh, lots of thinking faces. Okay, so those of you who raised your hand, what's the answer? Louder? 5 in red. Anybody has a different answer? 8 in blue. Okay, that's a slightly different answer. What else? No, 2 cards. Okay, so the answer is 8 and red. Now, less than 25% of people get this right, even people who are trained in logics and mathematics. And by the way, the reason is, if I turn blue over, I don't really care. If it has an 8, I'm happy. If it has a 5, I'm happy. Most people get the red and the blue wrong. If I turn the red around and it has a 6, we're in trouble, right? So I need to turn the red to make sure there's no problem. Why is this problem more difficult to solve than the previous one when they are identical? You realize they are identical, right? I mean, I just changed the sort of names in it.
They're not real-life scenarios?
Yeah, because this is a social problem. The other one is a social problem. You're trying to catch cheaters. The brain is really good at detecting cheaters. So they're exactly the same problem. And by the way, the guys who came up with this experiment, the way I've seen it is they always do it in the inverse order. So this is a bit of a torture test scenario because I'm doing the answer first. You get to do the easy one. And then you could just apply sort of the same logic. And even then, people struggle much more with this one. So I bet some of you, even though I explained it, you're still thinking like, why? Why is it the red one, right? It's very simple. There are no people in the story, no characters, and your brain will do much better whenever it's dealing with social things, which also is a very important element in learning. If you want to remember any of the stuff I'm saying, and on average people remember maximum 10% of what they hear, go and tell people about this. So when you're leaving and you're in the tube, just talk to your neighbor and say, hey, did you know whatever fact you thought was interesting? Or get home and tell people about it. the more you use it with other people, you're repeating the pathway, and you sort of have, the hook of I'm dealing with human beings. So you're making it a little bit bolder and a little bit darker. Okay, so brain truths. The brain's primary network is the social network. It's the one we go to when left idle. And we have a highly adaptable brain. So a bit of a summary. Imagine this, if you want to think of it in picture terms, imagine you had a huge Scrabble with, millions and millions of letters. Your brain is a bit of a filter, and just a few letters make it through. And then with everything else you have in your brain, you create a little story. So you see something happen, and you decide, oh, he clearly likes me, doesn't like me, whatever. And based on that story you tell yourself, you feel something. You feel angry, you feel happy. And based on that emotion, you then react, and the reaction could be to do nothing. And that reaction, that action becomes, another one of these cycles for somebody else. So the point is you can choose which letters you allow in, and you can play with how you put them together. And you can come up with a completely different version of the life you're having. So it's not so much what happens to you. It's the story you tell yourself about what is happening that makes the difference to how you live your life.